What we're facing at Volvo Cars, especially since we bought the DIM actually, is that everyone wants to start using the simulator, which is of course very interesting and very fun, but it's also very challenging. So traditionally you can say we've used the simulators first for HMI, which is maybe the more simple task. Secondly, it's active safety systems, and especially the less dynamic ones. Now we can start trying the more dynamic active safety scenarios and systems in the DIM simulator. We also now have us at Vehicle Dynamics, of course, that are responsible for the DIM simulator. Powertrain are starting to be interested. We have people from seat design that are very interested in using our simulator for ride evaluation. And coming in now is also complete vehicle testing, which is the department within Volvo that signs off the complete vehicle in the end. So they actually want to have the full experience, which is of course a great challenge.
One of the areas where we'll use the simulator in the very near future is to assess automated vehicles and the way how they behave. One of the things we do on the open track is assess a vehicle in its surrounding. But it's also assessing how the driver of other vehicles, the traffic around you, reacts to, for example, an automated car.
And this is also allowing customers that are working in electric and hybrid cars to develop the right sound for inside the car and outside the car.
So I can say that we're actually already running autonomous drive studies in our simulator. Just currently we're piloting the project before we take in any type of driver. So drivers that we have currently have been running have been somewhat involved in the development of autonomous drive. If the motion-based simulator is important, it's actually even more important because you don't have the cue of the steering, for example. You don't have the direct feedback, so you just have the indirect feedback of the motion of the vehicle. So although some studies have been tried in the static simulator, it's more or less pointless because there's too little information for the driver. So anything which might be uncomfortable or feel unsafe requires a motion-based simulator to represent this.
I have the example from Ferrari that bought at the same time the driving simulator from VA Grade and the NVH simulator from us. And it was a way to be more confident on the sound that Ferrari was delivering to the customers after the introduction of the turbocharged engine.
The most obvious thing is just that we can make things faster, front-loading the projects more, but not necessarily doing things too much differently. But what it is, it's a meeting place for everyone working with CE, or even not working with CE, but suddenly everyone can understand the CE models. So the possibilities of collaborating within the company or with authorities, etc. I think it's a very powerful tool for this. So in this sense it will change the process a lot. It would be the complete vehicle testing that then can come and try our concepts the first week of the project. What we at Vehicle Dynamics are mainly concerned with for the moment, that would be the ride dynamics, which means that we need to increase the frequency range of where our models are correct. And this applies both for tire models, it applies for the chassis model, and after that we have the correct output there on higher frequencies is of course also a question for the motion cueing and what the platform is capable of. Driving simulator is a very good entry point because you can show the other group that we're doing this, isn't this interesting? Wouldn't you like to try your model here? And then when we've implemented in the simulator, it's much more easy to implement it in all the other environments. Because we have so much data available in the simulator with much less effort than we have in a real car. We have all the objective data of the simulation, so we can see exactly what the driver reacted to. We cannot do this in reality to the same extent. So that gives us a very powerful tool.
Euro 6, you have to prove that you're able to have real-life emissions rather than a circle or a bandwidth that you drive, and prove that you have a proper setting on it. The next step will be that also the driver will be involved. And where we see today that with the e-Horizon and the fact that we have a simulated environment to run those type of tests and to do a proper setting on it, the next step will be that in a driving simulator you will be able to do that. So I don't expect that to be something very special. It will be a natural move where you will have emissions connected to the rest of your settings.
The fact that we can now integrate our more advanced powertrain models, etc., for especially our collaboration with drivability, means that we can try a lot of novel propulsion systems. For example, you probably all know that the combination in hybrid vehicles between the combustion engine and the electric motor is actually something quite challenging. And the interaction between all of these control systems and actuators and the driver is very important for how the driver can have a smooth and comfortable ride at the same time as the emissions are kept low. So including the driver in the loop here is of course useful, apart from just offline simulation. The portability of all these things gives very interesting combinations between the virtual reality and the physical world. So you don't need to necessarily restrain yourself to one or the other, and I think that's something that's going to change